is what we have. When we start, I want you to go on your paper, and I want everybody to go here. I want you to think of this as the start line. So if you're familiar with the track, everybody go here to this line right here, and this is the start line. Please do that for me. We're going to start by talking about the 30-degree angles. So if you took and measured from this line up to this point, this would be 30 degrees. So in this place, we're going to count by threes. So I'm going to start by marking, take your highlighter, because this will be valuable when we turn this into radian measurements. And notice that I am skipping some lines. These are all 30-degree measurements. So on your paper, starting here, we're going to start by really quickly just counting by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Now I'm going to go back and put a 0 behind everything. I'm going to finish off doing the degrees. So notice that this point is directly in between 30 and 60. Well, the difference between 30 and 60 is 30, just like the difference between 120 and 150 is 30. Between 210 and 240 is 30, and between 300 and 330 is 30. So if the difference is 30 and it's halfway in between, that means it's 15 above or 15 below. I think most often it's easier for students to go to the smallest one, which is 30, add 15 to get 45. Go to the smaller ones, which is 120, add 15 to come up with 135. Going down to 210, it's the smaller ones, adding 15 to get 225. 300 is a smaller, adding 15 to get 315. Now, I will tell you a shortcut that some students like. For me, I don't know if it really holds true, but for some students in the past, this is what they prefer to do. They start by, and when you're talking about these 4 that I have right now highlighted in blue, they start by putting a 4 and they count 9. Please watch. There's 4 plus 9 is 13 plus 9 is 22 plus 9 is 31. And then they just put a 5 behind it really quickly. You're going to be able to fill out this entire circle in less than 2 minutes. Okay, so we want to think of ways that you can quickly do it. We just finished measuring each one of these angles starting from here. So from here to here is 30. From here to here is 60. This is the start line. From here to here is 90. Here's 120. By the way, if you went and reversed your direction, it'd be a negative. This would be negative 30. This would be negative 90. This would be negative 180. Just like we have different ways of measuring distance, we have miles and we have kilometers, different ways to measure the same thing, just accurately with different units, we have different ways to measure inside angles. Most of us relate to degrees, including me. It's easy to relate to. We're used to working with degrees in geometry. The next way we are going to learn is going to be using radian measurements. I need you to know that this radian measurement, equivalent to 30 degrees, is equal to 1 pi over 6. This angle is 1 pi over 6. Now I'm going to first create these angles, and I'm going to do them using the pink. So I'm forgetting about the blue. Does everybody see that? The blues are different. So I'm only doing the pinks. This is always my starting line. I always start here and I go up unless I'm told to do the negatives, and you're not going to be doing that right now. So here we go. This is 1 pi over 6. And then when you add fractions, let me just come up to the side here. Let me flip this over. If I was going to add 30 plus 30, that's how I come up with the 60 degrees. 30 and 30 is 60. Well, if I was going to go if I was going to go I wrote this down wrong, 1 pi over 6 plus 1 pi over 6. Okay, the denominator is the same, and I get 2 pi over 6. We're going to reduce it later. So here's the quick way. You ready? Here's 1 over 6. Come up here. Here's 2 pi over 6. 3 pi over 6, 4 pi over 6, 5 pi over 6. Make sure you're skipping the blue, and 6 pi over 6. Now, before you keep going, there has to be some of you that are wondering, like, how did you decide on the denominator being 6? If I cover up, if everybody can see this, if I cover up here, and you only look at the top half of this unit circle, how many equal portions of 30 degrees lie in the top portion of the unit circle? 6. 1 over 6, 2 over 6, 3, 6, 4 over 6, 5 over 6, 6 over 6. Continue to number these, please. Grab the papers and back. So this is going to be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and we end one revolution or one time around at 12 pi over 6. Okay, the next thing we're going to do is we're going to go back and we're going to reduce if possible. Now, everyone in here is highly intelligent in math, but if I was maybe in a different class, I would do this a little bit differently if I knew students really struggled with fractions. For instance, I know 1 over 6 does not reduce, but if I grab my calculator, and again, if I'm working with somebody who's not good with fractions, I would tell them to go 2 over 6, and then they can hit math. Okay, let's go back here. So I have 2 over 6. If you were not great with fractions, you hit math, fraction, enter, enter, and we can see it reduces down to 1/3. So we're going to reduce this right now. Everybody, we're going to come over here, and we're going to write, we know this is the same as 1 pi over 3. So when you see 1 pi over 3, you have to recognize it's the same as 2 over 6. Just like 3 over 6 is the same as 1 over 2 pi. Now 4 over 6, they're both even, so it's the same as 2 over 3 pi. 5 over 6 cannot be reduced. So I'm going to circle right now the reduced ones, like 1 over 6 is reduced, 1 over 3, 1 over 2, 2 over 3. 6 over 6 reduces to 1 pi. 7 over 6 can't reduce. Okay, 8 over 6, they're both even, so 4 pi over 3. 9 over 6 reduces to, they're both going to be divisible by 3, 3 pi over 2. This reduces both even to 5 pi over 3. Can't reduce, and this reduces to 2 pi. So now let's come back here and let's talk about 45-degree measurements. I'm going to cover up the bottom again. Please tell me, think of these as slices of pie. They're called sectors. When you have this rounded outside, they're called a sector. How many slices of pie have an interior angle of 45 degrees in the top half? 4 of them. Did everybody hear Jose? There's 4. There's 1, 2, 3, and 4. There's 4. So guess what this is going to be? 1 pi over 4. Now this would be 2 pi over 4, but what is 2 over 4 reduced down to? 1/2. This is 3 pi over 4. It can't be reduced. This would be 4 pi over 4, which is the same as 1. This is 5 pi over 4, can't be reduced. Down below, this is 6 pi over 4, which is the same as 3 over 2. And this is 7 pi over 4. What we're going to do is we're going to practice just our interior angles. So I'm going to say something like 60 degrees, and you're like, okay, when I say 60, I think 6 in my mind. I'm like 6. Okay, I have to start here. I don't start counting yet. 3, 6. This is what I'd end up with. So on your blank circle, this is where you always start. You haven't counted yet. 60 degrees in my mind is 6. Okay, 3, 6. This is 60 degrees. If I told you 120, okay, 120. So that's like 12. 3, 6, 9, 12. Is it making sense to you? If I said to you 33, I'm going, remember, I'm skipping right here. So if you want to put on your blank one, if you want to put little boxes just around these 4 45s, feel free to do that. If I said to you 330 degrees, okay, I'm counting by 3s, starting here. So here's 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Here's 330 degrees. So from here all the way around is 330 degrees. Can I have a thumbs up or thumbs down, not based on speed, just based on understanding right now? Thumbs up or thumbs down if you understood how I just did that. Okay, now I'm going to throw us off here. You ready? The first time when I do this, I'm going to always give you a number that has not been reduced. So I would say things like 4 pi over 6. I will keep it right now in this form. Okay, everybody go to your blank circle. Go to your blank circle. Make sure that the one that has the answers is not showing. If I say to you 5 pi over 6, so if it has a 6 on the bottom, I'm going to exclude these. If it has a 6 on the bottom, I always start here. 1 over 6, 2 over 6, 3 over 6, 4 over 6. Here's 5 over 6. Did I say to you 5 pi over 6? Is that what I said? Here's 5 pi over 6, okay? On your paper right now, you ready? You're going to turn to your elbow partner, whether you know that person or not. I want you to find 9 pi over 6. Go. Count, show them where's, don't look at the answer key. Where's 9 pi over 6? So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi over 6. No, don't write anything down. We're just practicing. Yep. Would anybody like me to demonstrate real quick? Hand raise. How do I find 9 pi over 6? Quick hand raise. Okay, so I'm starting here. I'm excluding my 45s, and I'm counting. Here's 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, 7 over 6, 8 over 6. Here's 9 pi over 6, right down here. Okay, are you ready? Here's your next one. I want you to find for me 240 degrees. So think 24 in your mind. With your partner, go ahead. Where's 240 degrees? Think 24. You done? So I'm counting by 3s. 3, 6, 9, 12, 15, 18, 21, 24. Check with your partner. All cell phones away, please. All cell phones away. Okay, we're good? Yes? Okay, now I'm going to throw 4s in there. I want you to find for me 7 pi over 4. Now, hold on here. Now, this is the mistake a lot of students make. When you count by 4s, you don't exclude what I'm going to call the north, south, east, and west. That's not mathematical terms. But if you think of a compass, don't you guys think north, south, east, west here? If you guys know what a compass is, right? You still have to include those when you do 4s. So a mistake a lot of students make is they're only going to count these 4. When I find 7 pi over 4, I still have to go 1 over 4, 2 over 4. Okay, keep going. With your partner, find 7 pi over 4. So I start here, I don't count. 1 over 4, 2, 4, 3, 4, 4, 4, 5, 4. Sorry, 5, 4, 6, 4, 7 over 4. Go back. Okay, so let's start by writing down sine. The mistake students make is they want to say the word sin. It's actually S-I-N-E, and they abbreviate S-I-N. So it's S-I-N-E, but we abbreviate it as S-I-N. It's called sine. There's no sin in math, okay? Sine. Now, what is sine? Sine is going to be the opposite side over the hypotenuse. Trig functions are literally just a ratio. You're literally just looking at a triangle and you're identifying two sides. The two sides you identify are based on what is the procedures of the function you're given. Okay, next is cosine. And again, if you're somebody who really likes to know how do we write these down, this is the actual word, but we abbreviate COS. We don't say cos. There's no cos. Cosine. Cosine is the adjacent over the hypotenuse. And tangent, there's a couple different ways we can think of it. We can think of it as opposite over adjacent, or we sometimes say sine over cosine because these are equivalent. Now, I do know that most students in here are comfortable with the word opposite and they're comfortable with the word hypotenuse. Adjacent sometimes is confusing for them. So when we choose an angle of a right triangle, I can choose either angle. Let's call this A and let's call this B. I just want to go over some terminology with you right now. Let's go right now angle A. Let's identify angle A. So from angle A, if I had to think about taking a Nerf gun and I took a Nerf gun and I shot the little Nerf gun across and I hit the opposite wall, what side would I hit? I'd hit this side, correct? This is opposite. The hypotenuse is always directly across from the 90 degrees. It is also the longest side of a right triangle. The adjacent side will be one of the two sides that creates your angle, and it can never be opposite and it can never be the hypotenuse. So in this situation, if I chose random numbers, I'm going to put these out right now if you're just watching. We're going to say this is 3, this is 4, and this is 5, okay? So the sine of angle A, we can write this down as practice real quick. The sine of angle A needs to be opposite side over hypotenuse. Okay, that'd be 3 over 5. Because trig functions literally are giving you procedures to create a ratio. A ratio is a fraction. That's all it is. Cosine. Okay, I need to choose the adjacent side and write it over the hypotenuse. Okay, adjacent would be 4, hypotenuse is 5. So cosine of A would be 4 over 5. Now tangent, there's a couple different ways we can choose to think of this. So I think the easiest will be opposite over adjacent when I see a triangle. So tangent of angle A is going to be the opposite side, okay, that's 3, over the adjacent side, which is 4. Can I have a thumbs up or thumbs down right now if you're understanding how it's created? Now, when we think about the video that Mr. McFarland is presenting to you, and you may not have looked at it yet, that's okay, it hasn't been assigned. He explains how do we actually create, how do we come up with using this unit circle, how do we come up with these measurements? It's very important you understand how it's constructed. We'll talk about that when we get back from break. I'm now going to teach you a shortcut. So how many of you have watched the first video and you've watched how it talks about how do they construct the unit circle? Hands up high. It's okay if you haven't. Okay, everybody else flip to the very back. I'm going to teach you right now how we're going to use these and how we can do everything else in about 40 seconds. Okay, ready? Here we go. Everybody, I want you to make, okay, think of this real quick, and as this is my unit circle, okay? And this is my first quadrant. We call this quadrant 1, 2, 3, and 4, by the way. This is quadrant 1. They use Roman numerals 3, and this is quadrant 4. I got to think quadrant 4 would be 1 IV, right? Okay, thank you. So there's 3 places here. There's 30 degrees, 45, and 60. Now, this is the shortcut. The shortcut can save you a ton of time, and that's how I memorize this. The shortcut can save you a ton of time. You are going to make a U shape that goes like this. Watch this. U shape that comes down and comes back up. Please do that for me. Now, as you make this U shape, you're going to count. It goes like this. 1, 2, 3. 1, 2, 3. Please do that. 1, 2, 3. 1, 2, 3. And then we're going to, in our minds, we're going to take the square root of each of these. And if we can simplify it, we're going to do it. What is the square root of 1? Okay, so don't you touch it. Square root of 2. Square root of 2, though. It's ugly. It's irrational. What's the square root of 3? It's ugly. And by the way, if you're like, I don't really know what she's talking about, watch this. Square root of 1, beautiful. Square root of 2, ugly. Square root of 3, ugly. So, wherever you see a 2 and a 3, put a square root on top. Now, why did I not do that on 1? I didn't do it on 1 because I know the square root of 1 is 1. So I'm going to come back here. I'm going to write these down just like I did, and I have to put a 2 on the bottom of everything. So just watch. I come back here. I'm going to do it to the side we haven't done. And so I go 1. Okay, 2 is ugly. 3 is ugly. So it's 1, 2, 3. 1, 2, 3. And on the bottom of everything, you get a 2. Okay, you ready? Now, take your fingers like this if you're watching this video, and I want us to think about this line. If we can only go above or below this line, and we can pull 30 degrees above or below, where are 3 other points on this unit circle that are exactly 30 degrees above or below this line? Turn to your partner, go. Where are 3 other points that are exactly 30 above or below this line? Go. Use your fingers right now and show your partners. Go. This is 1. This is 1. This is 1. Look at my fingers. Do you agree these are 30 up? Yes or no? Are these 30 up? Are these 30 down? We're going to take this right here and we're going to copy that answer. This is radical 3 over 2, 1/2. This is radical 3 over 2, 1/2. This is radical 3 over 2, 1/2. Go. Each of these places has this exact same thing copied and pasted. So I take this like it is a stamp and I go stamp, stamp, and stamp. Okay, you ready? When you're done, we're going to look at 60 degrees. So here is 60. Where are there 3 other places that when you measure it back to what we think of as the x-axis, we think of it right now before we go more in depth with this, we think of this as being typically the x-axis, okay? Where are there 3 other places that if you measure, it is 60 degrees to go up to the point or 60 degrees to go down? Talk to your partner. Put your fingers on those. Where are those? This is 60. This is 60, right? This is 60. This is 60. So take this, and I want you to think of this as a stamp and stamp it here, here, and here. Go ahead. Jenny, you keeping up? Okay. And hopefully at this point you understand the exact same thing when it comes to 45. So it is 45 up, 45 up, 45 down, 45 down. So I'm going to take this and copy and paste it. Radical 2 over 2, radical 2 over 2, radical 2 over 2, and radical 2 over 2. Then I want you to take your paper and I want you to flip it to the back when you are done. We know this is a unit circle, so the radius of this circle is 1. If that's the case, to get out to this point, I would go 1 to the right, and then I don't go up or down. To get to what we think of as the north point, I don't go left or right. I just don't go left or right. I go straight up 1. To get to this point, which is at 180 degrees, I go to the left 1, and I stay. And then to go down, I don't go left or right. I just drop down 1. Now, I asked you to flip to the back, so please do so. And you are working with an incoming freshman. They have missed the first semester of school, and what they missed was plotting ordered pairs. So you draw a Cartesian plane. That's an XY axis. And you write down the point 5, -6, and you have to describe to them, where do you find this point? What would you say in terms of the 5? We have to plot this point. What do you say? 5 to the right. Now, how did you know to go to the right? Because it's positive. Okay, and then what else would I do? And then down 6, and then you'd make your point, and this is 5, -6, correct? Now, this point, they all look very similar. This is 5, 6, and this is -5, 6, and this is -5, -6. Give me a thumbs up or thumbs down if you understand the symbols on this, the positives and negatives. Now flip to this side. Ultimately, we just had ordered pairs. Do you see how what I'm going to refer to as the 430 degrees, I know it's getting messy. Do you see how I'm going to call these stamps? Do you see how these 30-degree stamps are exactly the same? I've got to change that. I've got to now put it in the correct spot. So in your mind, before we get to the next point in understanding trigonometry, think of them as X and Y values. In quadrant 1, what should all the X's and the Y's be? Positive. Now, in quadrant 2, what should the X's be? So all the X's get a negative sign. We'll later call those cosines. What about the Y's, which we'll call sines? They're positive. Now, in quadrant 3, so we think of it as X and Y's. Later, we'll translate that to cosines and sines. They should both be negative, so put a negative in both. And lastly, in quadrant 4, the cosines called the X's should be, so the cosines called the X's should be positive, and the sine should be negative. Now, I had a student, just like we call the Damien method that we talked about, or most of you heard about. It's a great way to remember things. I had a student that was forgetting, like, we think of these as X and Y's at the very top, right? X, Y's. But now when we do trigonometry, it has to be cosine first, followed by sine. And a lot of students are like, how do I remember? So there's 2 ways that I remember this. One is, please put a line underneath the C and the S. C in the alphabet becomes before S. But I had a student, like David made a method that we remember, that said, if you think of cable television, you think of cosine, CBS. Cosine before sine. So think of this, the cable television, the network CBS. CBS says cosine always comes before sine, and that's how they remember this. So you ready? Let's go back here. Everybody find 60 degrees. Put your finger there right now on the paper that has everything. Okay, you ready? What is the cosine? That's the first number. What is it? 1/2. Please find 135. Find 135. Okay, find 135. What is the cosine? Negative radical 2 over 2. Please find 7 pi over 4. 7 pi over 4. What is the sine? Negative radical 2 over 2.